Here we are trying to estimate a definite integral using midpoint rule. And the interval is from negative 0.5 to 3.5. And think of this as the value of a, and this will be your value of b. And therefore delta of x equals to b minus a over n. This famous formula will be applied here as 3.5 minus negative 0.5 divided by 4, which is 4 divided by 4, which is 1. This means that the intervals are of width 1. So if you begin with the left endpoint of the first interval as negative 0.5, that's where you start the interval, right? The next point will be 1 more than this because your step size is 1. So you do negative 0.5 plus 1, which is positive 0.5. x2 would be 0.5. And then you go another step 1, which is 1.5. x3 will be, again, another step, 1.5 plus 1. Then x4, when you get to 4, which matches with your value of n, then you should arrive at the right end point if you did all the math correctly. And indeed, 2.5 plus 1 gives you 3.5, which is equal to b, right? This is your a. Okay, so we now found all the endpoints of each interval. So the endpoints of the first interval is negative 0.5 and 0.5. This negative 0.5 will be the first interval. So you have a total of 4 intervals because we have n equals to 4. And the left endpoint is negative 0.5. The right endpoint is 0.5 for the first interval. Next one is 1.5, 2.5, and 3.5. These are the intervals. And then over here you have some kind of a function. I don't know what. Well, x cubed, I guess we can actually draw it, but you don't really have to draw it. The only thing that you need is, because we're using the midpoint rule, we have to find the midpoints of each interval. Okay, and how do you get midpoints? You add and divide by 2, right? Negative 0.5 plus 0.5 divided by 2 gives you just 0. Okay, so 0 would be the first, the midpoint of the first interval. And then you just continue. 0.5 plus 1.5 divided by 2, that's 2 divided by 2, which is 1. So it will be 1. Okay? And I guess by now you can kind of expect what the next one should be, right? The midpoint between 1.5 to 2.5 must be 2. 2.5 to 3.5 must be 3. So you can either get these by taking averages, or in our case, the numbers have some patterns, and we know that these would be 0, 1, 2, 3. So 0, 1, 2, 3 are the midpoints. And what is the midpoint rule? Midpoint rule is base times height. Height is like the function value at the midpoints, right? So x1 star, that's our convention for calling midpoints. x1 star is the midpoint of the first one. x2 star is the midpoint of the second interval. x3 star is the midpoint of the third interval. x4 star is the fourth interval, and we just have 4 intervals, so this must be it. Okay, so let's try to compute this. Delta x we just calculated to be 1, and our f of x is this function. This is our f of x. So and well, let's first write down what x1 star is. The first interval's midpoint is 0, right? So this is x1 star, x2 star, x3 star, x4 star. So it must be f0, f1, f3, f4, now f2, f3. And because f of x is x cubed, these are cubed. So it's 1 times 0 cubed, 1 cubed, plus 2 cubed, plus 3 cubed, which is 0 plus 1 plus 8 plus 27, and that's equal to 36. And that's it. That's the midpoint approximation of this definite integral with n equals to 4.